Okay, everybody. Here's the homework. On the binomial, I promised you I would do some work on this, and here we are. So we're going to look at the binomial probability distribution homework and how this works. Now, this is binomial, so remember for the binomial, n, x, little p. Okay, there's going to be only 3 things that we really care about for this. And we want to make sure, let me double check our levels, make sure everything's good to go. Looks like we are. Okay. So, okay, ladies and gentlemen, n, x, and p. So if we look at question number 1, it says a test consists of 10, that's useful information, 10 true-false questions. Okay. To pass the test, a student must answer at least 8 questions correctly. Okay, so you need to pass, you need to answer at least 8 questions correctly. Now, here's the thing. If a student's going to guess on each question, so that's going to be an important detail. You're going to guess what's the probability that that student will pass the test. So, in question number 1, what we're going to say here is x is the number of correct guesses. Okay? Now, they're asking what's the probability that the person will pass the test. And in order to pass, you got to get, at the very least, 8 questions correct. So you have to guess on at least 8 and get them correct. So this is the phrase at least 8, ladies and gentlemen, if x is the number of correct guesses. And I'm going to scroll all the way down here to start to use some scratch work. So if x is the number of correct guesses, okay, we now need to get at least 8 correct guesses. So now remember, this is a true-false test. So because of that, when we guess, we're either going to guess correct or we're going to guess incorrect. Remember, a true-false test. Now this is for a single trial. So the probability of guessing correct on a test here, and there's 10 questions, so n is 10. For a single trial, right, this is our successes, the number of correct guesses. That probability is 1/2, so that's going to be 0.5. Little p then is 0.5. Okay, now the complement of this, q, which is 1 minus p, 1 minus 0.5, the complement is also 0.5 here. So in order to answer this question here, we need to do the following. The probability of getting at least 8 correct guesses out of 10 questions, that's a probability of getting 8, probability of getting 9, these are all correct guesses, right? Plus the probability of getting 10. Now remember, 10 questions, 10 trials, little p is 0.5, and what you're seeing here is the x values that you need. Okay, so we're seeing the x values. Now, where's our applause? What we're going to need to do now is we're going to go to the TI here. So what we learned here in the TI is we learned how to use the binomial probability distribution function. We hit second distribution now. Scroll all the way down to binomial PDF. That's A right in here. Okay, now we may want to scroll in a little more. This is what we're going to look for. Okay. So hit enter. Now, the number of trials here, there's 10 questions. So n is 10. Little p is 0.5. It's a true-false test. X is 8. So we're going to paste this in. That's p of 8. So we're going to add now p of 9. So we repeat the process. Second distribution. Scroll down to binomial. PDF. That's A. N is still 10. Little p is still 0.5. But now X changes to 9. We're going to paste that in. And then we're going to add again P10. Second distribution. Go down to binomial. Binomial PDF. N is 10. P is 0.5. Little p is 0.5. Now X is 10. So what you're looking at, ladies and gentlemen, is really p of 8 plus p of 9 plus p of 10. You're looking at what we're doing right here. P of 8, p of 9, p of 10. And the final answer now is going to be, when I hit enter, we're going to get this answer here, and we're going to approximate to the nearest thousand. So it'll be 0.05, or we could go 10 thousandths today. 0.05468. Don't know what the solution's approximated to. So 10 thousandths, tenths, 100 thousandths, 10 thousandths here. Oh, we could do the nearest thousandths. Wow. There's a thousandths position. We're going to look at the digit to the right. It's a 6. So what that means here for us is we're going to add 1 to the 4, and this is 0.55. Ladies and gentlemen, here's your final answer. And that is how you handle question number 1 here. Okay? Question 1. So if we scroll, I think it scrolled up here. 0.055 is what they got. And that's exactly what we got. Okay? So verify your answer here for number 1. Okay? There we go. Now, number 2 is an interesting question. So number 2 says this. So we have a machine now. Okay, so the machine has 11 identical components in it. So if we start to read this, and they all function independently, the probability that each component will fail, I'm just going to notate this. Probability that a component fails is 0.2. Now, the complement of failing is it kind of works okay, I guess, or it really functions. And that's the complement. That's 0.8. So I just want to let you know that's for each component, each individual component. Okay? Now, here's what they're going to say with the rest of this. They say the machine will stop working if more than 3 components fail. So I'm going to have to really consider what they're saying here. If more than 3 components fail, the machine stops working. Okay, so they're going to say, now find the probability that the machine will be working. So maybe I can change this word to work for W instead of being okay, right? This is each component works. Individual component works 80% of the time, but it fails 2% of the time. They're saying find the probability that the machine will be working. So this is going to take some thinking here. So here's what I'm going to do here. Okay, remember this question was written by a publisher. It's not written by Mr. Judge. Mr. Judge would be a lot more clear, at least I think. But let me write this down. The machine stops working if more than 3 components fail. So question 2. The machine stops working. I think of stop working as the machine fails. And when does that happen? If more than 3 components, that's individual components, fail. So what I'm going to do now is this. I'm going to say X equals the number of components that fail. Because you're saying X more than 3, that's what's going to be. That's the more than 3 part here. So what I get out of this statement is more than 3. Remember, let your successes be what's in the question. It's kind of odd. Successes fail. You know what I mean? So, in other words, X is greater than 3. This is the situation where the machine itself fails. Okay, now I want to do a note here. This is more than 3. Let's note. The machine will work when X more than 3, that means 4, is less than or equal to 3. Okay, so let's think about this. This is the machine. X is the number of failed components. So when the number of failed components is no more than 3, the machine works now. So I'm going to stick with what they gave me. I'm not going to make life complicated here, okay? They're telling me that, you know what? If we let X be the number of failed components, the system, fails when it's more than 3. That's more than 3. Remember what more than 3 means. That's X is 3, X is 4, and so on, right? Up to X is 11 because there are 11 components. So the complement of a machine failing is working. And so the complement of more than 3 is no more than 3. And this is what we're going to end up using, because what they're going to ask us is, what's the probability that the machine works? Okay, when X is less than or equal to 3, when no more than 3 components fail. Now, stop and think about this single trial here, right? We have a single trial. Single trial for the component, so each component. So we're going to look at this in terms of 2 outcomes. It's a binomial. The component will fail, or the component will work. Now, they gave us information. They said the component fails 0.2 or 20% of the time. This is each individual component. That means it works. The complement of 20% is 0.8, right? So let's go back and see how we looked at things and defined things. I apologize here, right? X is the number of failed components. This is what we think of as a success. Okay, so little p is a probability of a failed component. That means this is my little p right here. P is 0.2, and it means Q is actually 0.8. So remember, we defined it this way. And N was 11. So ladies and gentlemen, let's go back and double check and verify question 2. Okay? Machine has 11 components. They function independently of one another. Okay, good. The probability that a component will fail is 0.2. So sure enough, we're correct. Right there. That's my little p. The complement is that the component will work. Because they're asking, what's the probability that the machine will work? So we set the table, ladies and gentlemen. We're good to go. Now, let's look at this number 2 here, right? Here's where we're at. They want to know the probability that the machine will work. It works when no more than 3 components fail. So we're going to actually copy this here, okay? And we're going to write down here what this means, right? This means x could be 0, x could be 1, x could be 2, x could be 3. Okay, these are my x values. N, remember, was 11, and little p is 0.2. So we have everything that we need. We have n, we have little p, we have all the x values here. This is the probability that the machine will work, because it works when no more than 3 components fail. 3 or less. So this is where the TI comes in, right? So the TI comes in now, and we're going to say n is 11. So I'm going to clear this out now. I'm going to clear this. We say second distribution, binomial PDF. That's A. Now this time there's 11 trials. Good. And this time little p is 0.2. Now the first value we need for x is 0. And that's going to be pasted here. Now we need x is 1. So we're going to repeat second distribution. Make sure we don't go down too far. N is 11, little p. Now x is going to be 1. We're going to paste that in. Plus, we're going to go up to p of 3. So now we do x is 2. Second distribution. A. X is 2. We're going to paste that in. Now we need x is 3. Second distribution. Too far. Binomial. Now x is 3. We're going to paste that in. So, ladies and gentlemen, you're looking at what we just did here. P of 0, P of 1, P of 2, P of 3. So when we hit enter, here's the probability that the machine will work. It is 0.83888608. We're going to approximate to the nearest thousands again. Okay. Here's a thousands position. Look at the digit to the right. It's an 8. So your answer is approximately 0.839. This is the probability the machine will work. Corresponds to 83.9% of the time. So let's double check. Right? Let's double check. Number 2, sure enough, we are correct. 83.9 or 0.839. 83.9% or 0.839 as an answer. So there we go. So we did get number 2 correct. Good. All right. Number 3 now. I'm going to erase some of this other stuff here. Okay, so it's not distracting us. I know there's not a lot of space, but, you know, it's better than nothing. All right. A certain college has 33% of its physics majors being minorities. Okay. If 10 students are selected at random from the physics majors, okay, find the probability that no more than 6 belong to an ethnic minority. So no more than 6 are minorities. So here's what we're going to say. X is the number of minorities. Okay? Because they want to know what's the probability no more than 6 belong to an ethnic minority. So that's in terms of X. X would be no more than 6 means 6 or less. Okay, so this is the meaning of no more than 6. It's 6 or less. No more than 6. Now remember, the probability of being a minority is actually 0.33. And you say, why? Why is that the case? Because they told you 33% are minorities, and the decimal representation of 33% is 0.33. Okay, so let's keep this in mind here. We got selecting 10 students. This is N. X is the number of minorities. Little p, here's my little p, ladies and gentlemen. Little p is 0.33. Because let's keep in mind for number 3, we write it down this way, right? Number 3 is going to look like this. You're either going to be a minority or you're going to be a non-minority. 0.33 and the complement is 0.67. So we said this is my little p, this is Q, X, number of minorities, so this is my success. Remember that? Count that as a success. That means little p is 0.33. So what did they say again about the number of students? They're going to select 10 students, so N is 10. So remember, for binomial, we need N. We need the values of X. And what did they say? We have N is 10. Being the minority is a success, so little p is 0.33. So what did they say in number 3? No more than 6? Yes, X is less than or equal to 6. So let's look at this now. So for number 3, they want to know what's the probability that X is less than or equal to 6. So by definition, that's p of 0 plus p of 1 all the way up to p of 6. Okay, so if you wanted to see every detail, we take p of 2 plus p of 3 plus p of 4 plus p of 5 plus p of 6. Remember, there's 10 selected students. I'm going to suggest you use the complement rule. The complement rule is always 1 minus the probability of the outcomes that are not here. So what is not here is p of 7. What's not here is p of 8. What's not here is p of 9. And then what's also not here is p of 10. So there we go. So we're going to enter this in the TI calculator now, okay, for number 3. So let's see, number 3 now. Here's number 3 here. Let's clear this out. 1 minus. You want to start that off because that's what this is here. 1 minus. Now p of 7. So you say second distribution, binomial PDF, which is A. N got changed back to 10. Now little p is 0.33. The first X value we use is 7. Like we said, we're starting with p of 7. And then we're going to do p of 8, p of 9, p of 10. So we're going to subtract those probabilities. That's minus p of 7 now, second distribution. X is now 8. Paste. Minus second distribution. X is now going to be 9. Okay. Paste. Minus second distribution. X will be now 10. Paste that in. And ladies and gentlemen, the probability is approximately, we're going to round out to the nearest thousands again, right? So we're going to put down what? 0.98145. We're going to put down some of the values here. So the nearest thousandths actually is right here. The digit to the right of that is a 4. So approximately 0.981. And that's about 98.1%, ladies and gentlemen. Anyway. It's as a percent. So let's double check to see if we're correct. Number 3. 0.9815. Well, I guess if we went to the 10,000s. This is the interesting thing that I like to say to you guys again. You know, this is what bothers me about some of these publishers kind of formats. They're not even consistent with the place value, right? So notice the first two are the nearest thousands, and then all of a sudden they go to the nearest 10,000s, and then 4,000s, and then 5 10,000s, and 6 10,000s. Not that big of a deal. But I would like consistency. So let's go back and see if we went to the 10,000s, right? Like the publisher, you know. This is what they did. This is now, oh, here's a 10,000s. Look at the digit to the right. Sure enough, it's a 5. So 0.981. Add 1 to the 4, and that makes that a 5. Now, ladies and gentlemen, if you went out to the 10,000s, this is consistent with the solutions by the publisher. Okay? Just wanted to throw that out there so you guys don't panic. Whoever wrote the question should have said, hey, please approximate to this particular place value, right? And I know I will, personally. So anyway, here we go. Let's start with number 4 now. All right, well, we lost our QuickTime, so I'm going to try to get QuickTime back. You want a new movie recording? Okay, there we go. We got QuickTime back. We lost it. Weird. So, okay, so number 4 says find the probability of at least 2 girls in 9 births. Again, publishers, they didn't write this very clearly. So what's happening is n is 9. You're going to have 9 children. Okay? This is our n. So n is 9. We're having 9 children here. Okay? Now, they're saying, what's the probability of at least 2 girls? Well, let x be the number of girls. Okay? Now, at least 2 means x is greater than or equal to 2. So I kind of want to just they were really short and sweet with the question. And then they say this, assume that the male and female births are equally likely. Well, we know that already. You know, the single trial probability of having a girl, right, for a single trial, we know is 1/2, which is 0.5. And that's going to be your little p here. So number 4 is an at least 2 question for having children. And n is 9. So let's write this down, number 4. Okay. X is greater than or equal to 9. Sorry, 2. N is 9. Little p, we said, is 0.5. That's a probability of having a girl. Because again, remember the single trial situation? You have a boy, you have a girl. X was the number of girls. Let X be what's in the question. Girls, so a girl is a success. So this is my little p. Here's my q, which is the complement, right? So this is a standard setting for having children. This is a single trial here. So at least 2 girls is the question. What's that probability? So remember by definition what at least 2 means. This means 2 or 3 all the way up to 9. This time I'm not going to write it all out. Okay? I'm sorry. Yeah, up to 9 because they're going to have 9 children. Yeah. So at least 2 is 2 or more. 2 or 3 or 4 or 5 all the way up to 9. Now, as you guys know, I like using the complement rule because it's always 1 minus the probability of the outcomes that are not in the definition. What's in the definition for at least 2 is 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9. So the complement is 1 minus p of 0 minus p of 1. Okay? So we have all the information we need. N is 9, little p is 0.5. Remember, this is for a single trial here, down here. It's a binomial. So let's see what the TI calculator says now, okay? So, clear. Now, this is a complement rule question again, so we have to do 1 minus. 1 minus second distribution, binomial PDF. Enter. Trials is 9 again, or changed to 9. Little p is 0.5. Remember, this is going to be the first x value. It's 0 because we're using the complement rule. So this is 1 minus p of 0 now. Now we have to do minus p of 1. So minus second distribution. Change the x value now to 1. Paste. And we have 1 minus p of 0 minus p of 1 now. So we're going to hit enter. And again, not quite sure where they said to approximate this place value. But this is going to be 0.980468. So what did they do? This is what I would do. I'm going to go back and say this is question number 4, I guess. 0.980, that's the nearest thousands, 3 decimal places. So I'd be like, okay, they gave this to the nearest thousands. I would like to have known ahead of time. Look at the digit to the right. It's a 4. So sure enough, it is 0.980, approximated to the thousands position. So this is a standard, having, kids question, really, in this case, having at least 2 girls. When you have 9 children, they really paraphrased it. Maybe paraphrase it a little bit too much. I don't know. But this is how we go about this kind of question, ladies and gentlemen. Take a look there, number 4. X is the number of girls. So having girls is a success in this question. So let's get rid of this information here. Trying to keep everything straight now. Look at number 5 now here. Let's see. Number 5 again is a component kind of question, a management question. A company purchases shipments of machine components and uses this acceptance sampling plan. Okay, so if you buy machine components, you're gonna have you're gonna have to sample these components and see. I mean, you're gonna select components at random, and you check to see if they function. Check to see if they work or if they're defective. So let's look at the language. They say, here's your plan. You randomly select and test 26 components. There's your N, ladies and gentlemen. Okay? So N here is 26. There's N. All right, so here's the acceptance plan. And you accept the whole batch. You're going to accept the batch if there are fewer than 3 defectives. Fewer than 3 defective. So remember, you always let X be, or X. X is the number of defective components. Remember, this is your successes. You let it be whatever is in the question. So that means fewer than 3. That means less than 3. Fewer than 3 is smaller than 3. And this is how we start to look at the question. Okay? This is what you accept. This is accepting the whole batch. If you check and there's, less than 3 defective. So less than 3 is like 2, 1, or 0. Okay, so this is kind of setting up the binomial distribution question. Then they say if a particular shipment of thousands of components actually has a 3% rate of defect. So this is what this means. The probability for an individual component to be defective. 3% is 0.03, ladies and gentlemen. Now remember, being defective is what we're going to call a success because you let X be the number of successes. So this is a success, being defective. Okay, I know it's odd. Don't look into it. So let me kind of look at this as this is question number 5 now. Let's look at this in terms of a single trial so you guys are with me on this. 3% defect rate. That's what we think of that. So number 5 now, right? And you say, okay, how do we handle number 5? Remember, each component, it's either going to be defective or it's going to be okay. 3%, and that's 0.3. Remember, this was our successes here. Okay? So that means this is our little p. Little p is 0.03. Now, the complement of 3%, okay, is in fact 97%. That's your Q, ladies and gentlemen. But, you know, this is for a single trial. Now, remember, N is 26. You're going to test 26 components. Fewer than 3 is what you accept the batch in terms of being defective. You have X as the number of defective components. So they want to know, let's read the question. I didn't even think I read the final question, number 5. What's the probability of accepting the batch? Let's see. What's the probability? Let's read this here. Right? What's the probability this whole shipment will be accepted? Yeah, less than 3 defective components. So it is that, okay? So that's the probability there. All right, so we're going to do number 5. And so now we say, how does that look? Number 5. Probability that X is less than 3. So that's P of 0 plus P of 1, right, plus P of 2. So I like this one by definition. Just add P of 0, P of 1, P of 2, because those are the outcomes that are less than 3, 0, 1, and 2. And you're going to enter all this information in the TI. N is 26. Little p is 0.03. So the TI is here to save the day on us on this, okay? So let's try this out, okay? So I'm going to clear things out here. And this is by definition. It's not the complement. So I'm going to start with the probability here. Binomial PDF. 26. Little p, let's remember, that's 3%, 0.03. Now we start with X is 0, and then we work our way up to 1 and 2. This is P of 0. Now let's add P of 2. Second distribution. X is now 1. Paste. Okay, now X is 2. So second distribution, binomial PDF. X will be 2 now. Let's paste this. Now, again, we don't know where they approximated to. I'm going to go to the nearest thousandths, okay? So I'm going to put down 0.9580227. I'll stop right there, right? Approximate to the nearest thousandths again. Here's the thousandths. Look at the digit to the right. The digit to the right is 0. So what that means is 0.958. We don't change the 8. We don't add 1 to the 8. 0.958, which really is 95.8%. So what this means, ladies and gentlemen, and that's bigger than 95%, right? So number 5, let's double check. 0.9580. Well, they did the nearest. Looks like they did the nearest 10 thousandths on that one. Okay. So let's go back and number 5. And you go, oh, you know, this is what I would say. Oh, look at the nearest 10 thousandths position, right? That's where they went to. And the digit to the right is a 2. So sure enough, You do not add 1 to 0. So it's 0.9580. And yeah, it's now consistent with the solution or the answer there. It's number 5. All right, pretty good. Pretty good. Okay, number 6. Let's actually get rid of everything so we don't confuse ourselves. You know, it's kind of these questions. I think the book questions are worded a lot nicer than these questions, you know, and then I word things a little bit better, but it's good to go through this. Okay, so it's going to say the following. An airline estimates that 92% of people on their flights actually show up. Probability showing up is 0.92. This is for an individual. Probability you show. This is what this means. It's 0.92. Okay. You know what that means? What's the complement? It means the probability of being a no-show is actually 0.088%. That's the complement, okay? I just want to get that from the first sentence. Now, the airline books 75 people on a flight, for which the maximum number is 73. Okay, let's think about what they're saying here. So they overbook. So the airline overbooks. In other words, 75 people, they book 75. And by doing that, you know, they have like a capacity for the plane to be like 73. Okay, we're going to have to think about what this means. What's the probability that the number of people who show up will exceed the capacity? All right, now remember what this means here. 73 is what they call the capacity. That's how much space they have on the plane. But what did they do? They overbooked this plane here. I don't know what color. Okay? They overbook, but the capacity is 73 here. So they're saying, what is the probability that the number of people who show up? So probability, number of people who show up. So X is the number who what? Show up. Probability that the number of people who show up will exceed. What does exceed mean? It exceeds the capacity. They're saying exceeds 73. So here, I'm going to put it down here. X is greater than the capacity. That's exceeding the capacity. This is what they want to know. You're going to exceed the capacity of 73. And then that means and here is 75. Okay, this is my and now. So if we really think about it, this is kind of what airplanes actually do. This is the management scheme on airplanes. What they'll do is they'll say to you, okay, we only have a capacity for 73, but we're going to overbook by a few. Yeah, there's going to be a chance that we have a problem. They exceed the capacity. And that's what they're saying. What's the probability you exceed the capacity, which would be what percent of the time do you exceed the capacity? So it's a binomial. Now, I'm going to do it down here. Maybe do here for number 6 here, okay? Close by. Let's think about this in terms of a single trial here. What does this all mean again? Remember, or you're a no-show. You show up, and we're going to get our right. You either show up or you're a no-show. Note to self, stop at Best Buy, get a new cord. Now, what did they say for number 6? Probability of showing up is 92% of the time. So, 0.92. Probability you don't show, complement is 8%. What's our successes? showing up. Ah, that's good. Show up. That means this is little p. Okay. Now, x is the number again. I can copy that maybe. Right? Copy it. And then they want to know probability that x is greater than 73. That's exceeding. That's more than. Probability that more than 73 passengers show up. So what does that mean? That means either 74 show up or 75 show. So this is a pretty good question by definition. Okay. Exceeding the 73, more than 73, because remember 73, this is the capacity here. I don't know what color. That's your capacity of the plane. All right, let's punch this in. How many? N is 75. How many passengers, right? Okay, good. How many people did they book? They booked 75. They overbooked. So let's see what the probability you exceed the capacity would be now. Okay? All right. Let's go to the TI. Clear that out. Second distribution, you're going to use the definition, not the complement. 75 for n, number of trials. Probably showing up again is 0.92, little p. And then we want x is 74. So this is a probability 74 people show. And we're going to add that to the probability 75 people show. Okay, so this is an interesting question. Change your x now to 75. Let's paste that. Okay, so P74 plus P75. So ladies and gentlemen, here's why the airlines do what they do. 0.01446. Let's round to the nearest thousandths here. 4 is in the thousandths position. The digit to the right is a 4. So that's really 0.014. Okay. And what that means that this is 1.4%. Okay. So let's think about this. Let me get some water here. Take a look. This is number 6. Okay. And number 6, by the way, if we look at this, it looks like they said, oh, they went to a more accurate place value. Anyway, they went to the 10,000s. Look at the digit to the right. It's a 6. Sure enough, because it's a 6, add 1 to the second 4, which makes it 5. So I'm just going to approximate to the same place value that they do, which is, as a percent, 1.45%. Now, here's the point I want to make. So number 6 is same as the solutions there. What that means is about 1.45% of the time for an airline that overbooks by 2, meaning capacity 73, but overbooks, adds 2 more, books 75 people. 1.45% of the time, based on the individual showing up, they're going to be over capacity. So in that case, they have to offer those little perks they do. They say, hey, who wants to, have another flight? We'll give you $500 and, you'll get to stay in a hotel, blah, 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 right? So they give you a free flight somewhere. They give you like a voucher, an extra flight. Yes, you get another flight going home, but you get a voucher for a second flight. And, if you have the time, then you do that. You say, yeah, okay, good. So that only happens, though, 1.45% of the time. So anyway, just to kind of let you guys know how this all works. It's interesting. So let's look at number 7, 8, 9, and 10. And when we do that, 7 here, according to a college survey, 22% of students work full-time. So I'm going to put number 7 here. So notice this, number 7. I'll put it here. Okay. So that's a single trial information. 22% work full-time. Okay. So I'm going to say full-time. And that's 0.22. And what does that mean then? What's not work full-time? So I guess you are part-time, right? AKA part-time. And so what's the complement of 22%? Now, if you don't know, okay, you can say 1 minus 0.22. That's the complement, right? Which is 0.78. This is a single trial here. All right. So, I mean, I get that information just by reading, this is number 7, reading that first statement. And then they say, find the mean for the number of students who work full-time if the sample size is 16 now. So this is N, 16. Okay, so N is 16. So what do they want? They want to know what's the mean. Now, this is a binomial. Mu is NP for a binomial. So mu is 16 times, what is P? Find the mean for the number of students who what? Work full time. That answers, that's going to be, let's put that in red. Full-time workers. Okay. Okay. So this is our successes, full-time, 0.22. So multiply by 0.22, 16 times 0.22. Now, they didn't say where to approximate, which is kind of annoying to me, as you guys know by now. 16 times 0.22, and we get 3.52. So this is the mean, ladies and gentlemen. Number 7, the mean is 3.52. And, sure enough, for number 7, yes, 3.52. Okay. So just going through and reading that one, number 7 here. Okay, so number 7 was according to survey. So, if you selected 16 students, 3.52 will work full time. That's the mean, the expected value. Work full time. Okay. All right. Now, let's see. What is number 8? So let me erase some of this stuff. Number 8 is a multiple choice test with 21 questions. So kind of by now, you go, I know what that is. N is 21. Yeah. Each question consists now of what? 4 possible answers. All right, so what does that mean? For each question, the probability you guess correct is 1 out of 4, which is 0.25, just so you guys know. That's what that information always means. If there's 4 possible answers, probability you're not correct, the complement is 3/4, or 0.75. So I just got that information by reading that each question is 4 possible answers. Now, look at what they're asking here in the question here. Right, for students who guess on all the answers again, well, I guess there's 21 questions. They're going to guess on all 21? I guess that's what they're saying. Find the mean for the number of correct guesses. So mu for the number of correct guesses. Now, that just means the following here. For number 8 now. Sneak it in here. You either guess correct I guess non-correct. 0.25, 0.75. The mean, mu, is NP. For the number of correct guesses now, this is our success. So this is going to be, I want to get red. My P is 0.25. Now, remember what they said N was. N is 21 questions. So they're guessing on all 21 right in here. N is 21. Not yikes. All right, number 8. So what that means is, for number 8, mu, 21 times 0.25. So we can expect 21 times 0.25. This is what we can expect. 21 times 0.25 is 5.25 correct guesses. So if we guessed on all 21 questions for multiple choice, if we guessed on all of them, 5.25, ladies and gentlemen, is going to be correct. This is the expected value or the mean. Now, this is for question number 8. So question 8, sure enough, 5.25, they approximated that to the tenths here. So like I said, this is kind of a random approximation for these guys. And that's something, I know it drives students crazy because students always ask that question. What do we approximate, right? So that's question number 8. So you guys can see that there. It's a pretty good question. And I'm going to start to kind of erase some of these things, okay? It's in the video, so that's great. Just so you guys know. So let's see what number 9 is. All right? Start to erase this stuff. Gets distracting. Number 9. What does number 9 say? A company manufactures batteries, batteries in batches of 11. So it's a batch. Batch of 11, that's N. So whenever they make a cookie batch, a batch of cookies, well, this is a batch of batteries. And then they say there's a 3% defect rate. So once I see 3% defect rate, probability of an individual battery being defective is 0.03. That means the probability of being working, defective, work, or okay. What's the complement of 3%? That's 97%, ladies and gentlemen. And I'm going to erase this too. So, chew on that, or look at that. Look at that here for you guys. Just reading that first sentence there, right? Number 9. N is 11, 3% defect rate. That means a 97% okay rate. Find the standard deviation for the number of defects. Oh. Find the what? Standard deviation for the number of defects. So we got to be careful here. Sigma, standard deviation, is the square root of N, P, and then Q. Okay? Now, the significance of saying the standard deviation for the number of defects, what that means here is defects are the successes. That means this is little p, right? Probability of a success for a single trial. That's what that means. So P, this portion is 0.03, and then the complement is 0.97. So, okay, standard deviation, sample size N, oh, that's 11. 11 times 0.03 times 0.97. So the standard deviation we can get in the TI now. Okay. So, clear. Second, square root. 11 times 0.03 times 0.97. And this is going to give us a decimal answer. But notice, I wonder, 56577. I'll stop right there. I wonder for number 9, I guess. Oh, they gave an answer there to the nearest thousands. So what we'll do is give an answer to the thousands. Here's my thousands position. Look at the digit to the right. It's a 7. Standard deviation is 0.56. That 7 says add 1 to the 5, and sure enough, you get 6. So sure enough, ladies and gentlemen, this is exactly what we got in number 9 right in here. 0.566. There we go. All right. And that one is number 9, by the way. Okay. And let me erase this and say number 10 so you guys know what number 10 is here. Language and process. Number 10. All right, let's read number 10 now. Let's get rid of this. What does 10 say? 10 says, on a multiple choice test, again, of 12 questions, now we've seen this kind of stuff, n is 12. See what they say now for number 10. Okay. Each question has 4 possible answers again. Oh, we've seen this. 4 possible answers. Okay. And you're going to guess which is, one of which is correct. Okay, we know. So, start this off again. Correct. Incorrect. 1/4, which is 0.25. The complement is 0.75. This is your single trial for number 10 again. Okay, how many? N is 12. 12 questions. Now let's look at the question. Oh, find the variance for the number of correct answers. Variance, ladies and gentlemen. And okay, let's get back our calculator. Got to get a new cord at Best Buy. Who knows what's going on? Okay. So correct. See this? Find the variance for the correct answers. That means the successes are correct. That means this is little p. Okay, little p. All right. And that's now variance. So the variance is sigma squared NPQ. That means our complement here is Q. So our variance is going to be 12 times N. Well, that's N is 12. Excuse me. Little p, 0.25. Little q, 0.75. This is the variance. Now, the answer is in the nearest hundredths, so let's keep it that way. So let's go here, calculator. 12 times 0.25 times 0.75. And ladies and gentlemen, happens to give us an exact answer. This is not even approximate, 2.25. Okay? So that's not even approximate. This is completely exact. So we went over all 10 questions and notice we got all 10 answers correct, ladies and gentlemen. So I hope you enjoyed this demonstration. Take care, stay safe, and we're going to now try to do Poisson here, okay? Thank you.